For this question, we want to find f plus g, f minus g, f times g, and f over g. And we want to find the domain of each one of those combined functions. So I'll start with calculating f plus g, f minus g, f times g, and f over g. F plus g of x will equal f of x plus g of x. So this notation of f plus g is telling us how to construct the function. It's telling us that we have a function named f of x, and f of x is square root of x. And we have a function named g of x, and g of x is x plus 4. And we want to add those individual functions together. So f of x is square root x, g of x is x plus 4, and none of these are like terms, so we would leave it just like that as far as simplifying. For subtraction, we're going to take the function f of x and subtract g of x. F of x is square root x, g of x is x plus 4, so I want to subtract the whole function g of x. So I'm putting parentheses around it, and I'll use a distributive property on that minus. So I have square root x minus 4 for f minus g of x. And then we want to have multiplication. F times g of x is f of x times g of x. F of x is square root x. G of x is x plus 4. I want to put parentheses around x plus 4 to make sure we multiply the whole function together. If we were simplifying this, I would use the distributive property to get x square root x plus 4 square root x. And that's about as far as you can simplify it. Then we'll look at f over g, f divided by g. That's f of x divided by g of x. F of x in the numerator and g of x in the denominator. And there's not really any simplifying that we can do there either. So we've found f plus g, f minus g, f times g, and f over g. Now we want to find the domain for each one of these functions that we've constructed. In order to find the domain of the combined function, we have to know the domain of the individual function. So let's start off with f of x. F of x is equal to the square root of x. Well, f of x is the square root of x, and I would put that in the category of an even root function. So it's a root function because of the radical, and it's even because this is a square root. Even refers to the index on the radical. This is a square root, so that index is 2. And just as comparison, if you have cube root, the index would be written right here on the radical, on the left of the radical, and that's an odd index radical. Now with even roots, if you take the even root of a negative number, you get an imaginary number. And we only want to deal with real numbers when we're talking about domain. So we want what's underneath the radical to be positive or equal to 0. So we take the expression that's underneath the radical, and we're going to set that expression greater than or equal to 0. Greater than 0 for positive, and equal to 0 for 0. That gives us the domain of f of x. So the domain of f is from 0 to infinity. Then we'll look at g of x. G of x is x plus 4. I would categorize this as a polynomial function. More specifically, it's a linear function. And what we know about polynomial and linear functions is that the domain of these is all real numbers. So the domain of this function is negative infinity to infinity. Every number on the number line. So when we create a new function that is based on these individual functions, we have to consider the domain of the individuals. So sometimes I like to draw a picture to help me with this. So let me zoom out a little bit. And I'm going to draw a number line to represent the domain of f, a number line to draw the domain of G, and then we want to combine these two domains to find the domain of f plus G, f minus G, and f times G. So, domain of f plus G, the domain of f minus G, and domain of f times G. All three of those are going to be the same. Notice I left off division. I'll explain why I left off division in just a moment. So the domain of f, I'm going to mark out the 0 on there. I would put a closed circle because 0 is included, and shade to the right of 0. So the domain of f are only the numbers from 0 to infinity, including 0. With G being a polynomial function, I would shade the entire number line because the domain of G is all real numbers. When we combine the functions together with adding, subtracting, and multiplying, we have to consider the individual domain. So I'm just going to circle the part. In f plus G, we have the square root. In f minus G, we have the square root of x. In f times G, we have the square root of x. So on every single one of those, I have the square root of x. So that limits the values of x that I can choose. So if I look at where these two sets overlap each other, these are the values that I'm allowed to plug into the combined function. So to the combined function, I can start with 0 and substitute any number that is greater than 0, and that's because of that square root. Now, to throw in the division, so let's talk about the division. Domain of f over G. We still have to consider the two individual domains. However, there's a new thing that we have to consider. Remember, with division, dividing by 0 is undefined. So because we're dividing by x plus 4, we might have a new value for the domain to exclude. So if I take that denominator and set it equal to 0, I'm going to get -4. And -4 is not allowed to be substituted into this function. However, if I look at the numbers I said we're using, we only said from 0 to infinity, and -4 is way over here. So the statement that x needs to be greater than or equal to 0 already excludes -4, so I don't need to do anything extra to exclude that value. So the domain of f over G is 0 to infinity, just like f plus g, f minus g, and f times g. Thank you for checking out my videos. Have a great day.